Hi, I'm David. So for this problem, we're given g of x is equal to 3x minus 4, all of it over negative x. And they're asking us to find the domain, the vertical asymptote, and the horizontal asymptote. So what we could do is use our graphing utility to just plug this in and graph it. Right? They're just asking us to use the graphing utility to see what the answers are for this. So once you plug it in, right, just plug this in word for word, number by number, you'll see that the graph has a vertical asymptote at 0, a horizontal asymptote at negative 3, and the reason for that is at 0 is where x would make the denominator also equal to 0. As we recall, vertical asymptotes are created whenever this denominator approaches some sort of result that is 0. And since the denominator is simply x, this whole thing can't be equal to 0, so x can't be equal to 0. And that's why we have a blank space right down the vertical axis, right down the y-axis. Meanwhile, we see that there's a horizontal asymptote at negative 3. The reason for that is because we look at the degree measures of the x's. Because these two x's have the same degree measure, which is just 1, there's technically an invisible 1 here, both of them. Because the degree measures for these two x's are the same, we can just take their coefficients and divide them by each other. Technically, there's also an invisible 1 here. We just didn't include it. So then what we're really doing is saying 3 all of it over negative 1, which can be simplified to just negative 3. And that's why we have a horizontal asymptote at negative 3. And meanwhile, for the domain, we ask ourselves, well, what are all the possible values for x? Well, x could be anything except for where the vertical asymptote exists, right? So x could be anything. Anything you plug into x would work unless the denominator of the fraction becomes 0. So the domain would be all real numbers except at x equals 0, which is the vertical asymptote. So x cannot equal 0. That's another way you can describe this, is x cannot equal 0, or you can simply say that the vertical asymptote exists at x equals 0. It's the same thing. And that is how we solve this problem. Thank you.